You have seen the news. I am not going to talk about the whole Terra blockchain scandal, the whole Terra blockchain disaster. I am going to talk about a very particular scenario that we saw. And if you haven't found out, it turns out that the developers or the administrators of the Terra blockchain halted it. Like, okay, well, I thought blockchains were decentralized. No, they're not.
Net2Dev.
They're not decentralized. However, not all of them are decentralized. There's blockchains that are decentralized, and there's blockchains that are not decentralized. They're relying completely on centralized infrastructure, which means that if you are intending to deploy a blockchain-based application, Web3, anything that has to do with governance, DAO, validation, authentication, voting rights, anything that has to do with blockchain, you need to know where are you developing. And when I say you need to know who is in control. Is it truly decentralized? So it means that if I'm going to invest time and money, can someone else dictate if I can operate or not operate? And I think this is the goal in a blockchain, is to get us to a point that there is not a single individual or a group or a government that could stop it from operating. And this comes with all the debates that I'm not going to go into that rabbit hole. Freedom of speech, censorship, etc. I am talking from a developer standpoint. If I am going to be developing and spending countless nights, weekends, days, money, and effort to develop a platform, to develop an application that is going to be working in XYZ blockchain, I need to make sure who is in control. Is it truly decentralized? Because if, let's say, not saying this is the case, but let's say I want to operate in a certain way. I want to make sure that my blockchain does XYZ transaction, and certain government is doesn't like that. Well, up to what point do we know? At what point do we know that the government can actually influence and the owners or whoever is controlling that blockchain? Okay. Well, it turns out with Terra, it's a great example of why you need to make sure that the blockchain that you select to develop your Web3 applications are not centralized. How do we know that? I am going to jump right in. I'm going to show you not going to say this is 100% the way of finding out if the blockchain is decentralized or not decentralized. However, it can give you a lot of clues deciding if you should go with that blockchain or not, because after you spend years developing an application, you have it up in production, and you have a business running thanks to that blockchain application, well, what's the guarantee that the application will stay online? If we saw it, Terra just halted the blockchain. And you're like, well, that's where we go into validation consensus. So the way that we make sure transactions are valid is with validator nodes, which in this case are validating the transactions on the blockchain. Every single block has been processed, has been validated with a consensus validation mechanism. In this case, proof of work, and we know proof of work, it's done with mining machines, very powerful ASICs, or GPUs who are literally doing the whole validation mechanism to make sure that the transactions are legit. With other consensus validation mechanisms, we have to be very careful because we might be relying on centralized infrastructure. I'm not saying that the proof of work is the best one. I'm just saying that we need to find the least centralized blockchain possible. All blockchains are centralized. And this will spark a debate. I know people on the comments are going to start talking, no, that's not true. There's blockchains truly decentralized. There is centralization on every single blockchain, including Bitcoin. Because Bitcoin does proof of work, and we know it, and it's all controlled with proof of work mining machines. So the mining ASIC miners are currently in charge of dealing with transaction processing, okay? And the mining power on the Bitcoin network is controlled with pools. So everyone wants to get a piece of that block reward, right? That's why you cannot mine solo. You cannot decide to mine completely independent, because chances are the possibility of finding a block and getting a reward is very hard, right? So then you join a mining pool, right? You join a pool where there's other miners, and obviously because you have a group of miners running all at the same time and processing transaction, if you participate into that group, chances are they're going to find a block reward right away. Well, they do the split the earnings amongst all the miners based on your mining power, okay? So here's the thing. That's still centralized somehow, because the pool is literally controlling and dictating the validation mechanism, right? And there's multiple pools. I'm not saying that, it's only one pool. There's multiple pools. But still, you have some sort of centralization right there. Like if that goes down, or those pools are down, then your blockchain will be affected, will be impacted, right? Because transactions will take longer to process and whatnot, because the lack of hashing power will make the blockchain slower. So at that point, it's still centralized, right? But this video, I literally want to not raise alarm, but I want to bring consciousness in which blockchain do you choose to develop your applications. Because the saddest thing that could happen to you is that after you have a beautiful, fully working, fully adopted platform or application, the blockchain decides to halt. It's not going to be a very good day for you, okay? So let me show you. One of the things that we're going to talk about, or at least I am going to be focusing the video, are the RPC addresses. The remote procedure call, that's the address that you as a user of the blockchain are going to interact with your wallet. You point your chain ID, that basically tells the wallet, hey, this is the particular mainnet that I'm going to be communicating with, and then you provide the RPC address, which in this case is a fully qualified domain name. It's a DNS address, and there it goes. Another resource or another communication mechanism that relies on domain name service, address resolution, which is DNS servers. So that address, that RPC address, if you go to your MetaMask right now and you go to your networks, you're going to see RPC addresses. So those URLs, those addresses are resolved to IP addresses, because your machine does not know how to get to google.com. All it knows is how to get to an IP address. But to make the web adoptable and usable by everyone, no one is going to remember IP addresses. So they decided to do DNS. And DNS, what it does, it gets a name and it maps that name to an IP address, right? So, two things. I am going to talk about DNS address resolution. Okay, how do we connect to an RPC address? We're going to take the Terra ecosystem as an example. I'm going to look for those RPC addresses. We'll resolve the names. We'll see the IPs, and then we'll do quick social engineering, a quick dig into the details to see where that goes. So let me jump right in. We're going to take a look and see how can at least get an idea of how that blockchain communicates, and we'll go from there. Okie dokie, let's take a look real quick. What can we do to find more information about a particular blockchain? So let's go ahead real quick. So I'm gonna go my browser. So the first thing I'm going to do, I am going to obviously go to Google, right? So we're gonna go to Google, and then we are going to search. In this case, let's take a look at the Terra RPC, okay? Let's go to RPC. Okay, so those are the RPC endpoints. So what we can do, we want to resolve this. So the first thing I gotta do, I got to resolve this URL to an IP address. So how can we do that? We can actually, simple as pinging it. If you're not into IT, but you want to know what ping is, it's basically a way for me to test that I'm able to reach a certain destination on the network, on any network, either private or internet, okay? So we can open our shell command line. So what I can do, escalate myself. Okay, cool. So what I can actually do, I can go ahead and ping this address. So let me go and copy it real quick. Right, I'm gonna go paste, and we are going to see what does that show us. Okay, so right now that address is resolving to client your server.de. .de, I assume this is Deutschland, Germany. Well, we'll see. Okay, so let me stop this, and now I'm going to copy this, and I have a cool curl script that I can use to find more information about that. Okay, so I can do an API call to curl, and I can say HTTPS API hacker target.com. Then I am going to call the API, which is, by the way, I am going to look first for a BGP autonomous system number, or ASN, which is, if you don't know networking, BGP basically allows us to have an internet, right? So BGP is literally the routing protocol that allows the internet to exist. So it's quite a big deal. Okay, so we are going to try to find that. And the information that I'm getting, by the way, this is an API, open API that you can use to get more information from a network standpoint. So this address belongs to this BGP AS number, which BGP, I'll need a full 20-hour video to go over BGP, but I am not going to do that, obviously, in this video. But we got the AS number 24940. This is the block that this IP it's part of. This is the entire address space, and it belongs to this company. And this is Hessner AS. So that will be the AS autonomous system for Hessner. So guess what? I'm gonna copy, Control C. I'm gonna do some dig into that. I am going to paste that right there. By the way, I'm gonna just copy selection. I'm gonna paste that selection, search, and guess what? I have Hessner.com. So yes, so okay, so let's go and talk about this. So if you use this public RPC to connect to the Terra network, you're actually hitting a server that is hosted here in this provider. This is a cloud hosting provider, or a server hosting company, right? So probably they have a bunch of servers that you are literally talking once you establish a connection here. So let's say I want to talk to the Terra mainnet, right? The way that I do is I point myself to one of those addresses, right? And I can talk to that, okay? So if I go to my MetaMask wallet, I will have the same thing. Like if you go MetaMask, connect to Polygon, and we are just opening the first one, and we should get that information right here. There you go. So if we want to know, in order for me to connect to the Polygon network, I have an RPC address, which is basically the address that I need to point my wallet to in order for me to connect. So guess what? Terra, it's hosting in this particular, at least that endpoint, that RPC endpoint, it's there. It's pointing to something, probably it's a server that they're hosting in this company, okay? So let's continue. Let's take a look at another one. Let's see, this is a different, if you can see, this is a different domain name. So what I'm gonna do, I'm gonna copy this link. We're gonna do the same thing. I am going to ping that, and in this case, I'm going to paste that right there. And I just remove the port. We're just gonna leave fully qualified domain name. And this one is resolving to 104.206.14.17. And let's now find more about that. So what I'm gonna do, I am going to, again, copy selection, and I'm gonna bring my good old curl API call. I'm gonna paste my address right here, and let's see, Cloudflare. Okay, so Cloudflare, it's cloud service provider that allows you to point to their services for DNS resolution or CDN, Content Delivery Network, which is a way for me to spread the request into multiple destinations. So let's say you have something as active as a blockchain. You don't want to send every traffic from the globe, from all around the globe, into a single destination. So what you do is you spread that load. You load balance those requests to different destinations. So like you can either land in the US. If you're close in the US, your closest destination will be in the US. If you're in Asia, will be in Asia, and so forth. Okay, so this is a way for me to spread the load between the globe locations. So between the globe, geographically dispersed reachability. So you have a path that is closest to you. Okay, so with that said, this right here tells me that this blockchain, it's relying on centralized infrastructure, right? Because you still rely on Cloudflare to resolve that address, or at least communicate. You're not technically talking to a decentralized destination. You have to land on a centralized destination. And again, I'm not saying that that's good or bad. What I'm saying is, if you want a blockchain to be truly decentralized, the operation in the blockchain, it could be decentralized. You can be spread across different locations, and you might own those resources to operate. It might not be hosted on someone else's, but your clients are not going to be able to reach to your blockchain in case there is an issue with those resources, right? So that's something you have to take in consideration when you want to deploy an application, okay? And which blockchain do we want to deploy to, okay? So let's take Polygon, right? I'm gonna go Polygon, and let's do the same thing. I am going to ping, I'm going to paste, and let's see this guy. 104.18.11. So let's see who is the owner of that IP address. I'm going to copy, and I'm going to bring my good old curl script. And what we're going to do, we're going to right click, we're going to paste, we're going to press enter. Cloudflare. Okay, so every single again, this is not financial advice, nor I am saying that this is bad. What I'm saying is, guess what? Your RPC URL is this right here, but they have other RPC URLs. So let's try to resolve this one instead. The problem is, if this goes down, so if Cloudflare suffers an outage, right? Because we can see that that's pointing to Cloudflare, right? This is, if I go to Cloudflare, right? If we go there, that is a centralized resource, or that is a centralized service. They host, bunch of data centers, and they host data centers, and they host servers, right? So, or services, network, etc., SaaS, software as a service, you name it. However, this is centralized. So if they suffer an outage, you suffer an outage. You're not going to be able to communicate using this RPC address, right? And they might say, well, yeah, we're 99.9 uptime, our SLAs are 99.9 uptime. And yeah, but here's the thing. When we want, the end goal of blockchain is to have no control. Like the blockchain will operate and no one can dictate upon it. So let's say, I am not saying that's the case, but let's say the government, whoever governments wants to stop a particular blockchain because they are not in agreement with what they're doing, they're not gonna target the blockchain. They're just gonna talk to these guys who are probably working and earning in that particular country, and the country will trick this particular service provider into saying, oh, guess what? If you want to keep operating in our country, you have to do this. That's why centralized infrastructure is not the way to go with blockchain. So I know that there's ways to go around that, and at least there's projects out there that are looking to at least not rely on DNS with cloud providers, because right now this is literally pointing to a cloud provider. So that's my point. And the fact is, not blockchains are not truly decentralized. You know, Bitcoin, I bet we're going to find Bitcoin right now. At least I'm going to take a look at this one. I'm curious to see the second one. Hopefully it's not Cloudflare. CloudFront. So this is literally pointing to another server, and guess what? LAX is Los Angeles, so this is hosted in Los Angeles. So CloudFront, it's another service similar to Cloudflare. Okay, so if you want to be truly decentralized, guess what? It's our good old friend Jeff Bezos. So Amazon CloudFront, it's a service in AWS. So this is another cloud, another centralized infrastructure that is allowing you to connect to the Polygon network. Again, I am not bashing Polygon by any means. I am literally just showing you as educational purposes only. But here's the problem. We want blockchains to be completely decentralized. I myself want the blockchain, or Internet 3 or Web 3, whatever you want to call it. I want that to be completely decentralized. I don't want to rely on centralized infrastructure. That's the whole point of decentralized networking, right? So with that said, let's go ahead and try one more, and then we can take a look at Bitcoin. This is literally Cloudflare. I can tell. The 104 space, I think it's Cloudflare. So we're gonna go curl. Yeah, it's Cloudflare. It's literally Cloudflare. Yeah, so Polygon, literally it's all, at least it's all communicating using Cloudflare. So if you lose Cloudflare, let's say they have an outage or their service is impacted, because they might not have an outage, but God knows what happens with Cloudflare and Polygon, you will not be able to connect. So the RPC, this one in particular, goes to another service, which is AWS, it's Amazon. Okay, so you have to be very careful what service do you choose, right? And finally, let's go and check for Bitcoin. Bitcoin RPC. And let's take a look at that. Address, P2P network. And let's take a look at the network. This is literally how to talk to the network. Let me see, I'm looking for... so it looks like, yeah, so if you can see here, the way that Bitcoin allows you to connect, it's not a simple URL. Like, you have to probably look at a client that client will allow you to connect. And we'll have to dig inside Bitcoin. This is actually a good thing, because it's not as simple as pointing to a FQDN or an RPC address. It literally is dependent upon it's true peer-to-peer. It's just like, you know, what is very similar to Bitcoin? It's BitTorrent. So BitTorrent uses peer-to-peer. So you just swarm addresses and you find peers that way, swarming the internet, and that's how you can communicate in JavaScript. So it's not a simple RPC URL and done, right? So I'm gonna wrap it up here. There you go. Be safe out there. Be careful out there. It's wild, wild west on the crypto space right now. But one thing that we can at least mitigate and try to avoid, it's research. If we research, at least we're not 100%, we never are, nothing is perfect. Nothing is perfect in this world. But at least we did our due diligence and try to mitigate risk, okay? I hope this video was very informative. If you like my video, please give it a thumbs up. Subscribe if you haven't subscribed to, and we'll see you on the next video. Bye.